Welcome to This Explainer. Today, we're diving into the incredibly critical and honestly surprisingly huge world of work equipment safety protocols. Understanding these guidelines isn't just about ticking off a compliance box for human resources, it's about fundamentally securing your workplace. Whether you're running a massive industrial plant or simply overseeing people using basic power tools, these principles are absolutely non-negotiable. So, why does all of this matter so much? Well, just take a look at this staggering number. In a single recent year in the UK, 13 workers lost their lives and over 2,500 were injured. How? By simply coming into contact with moving machinery. These aren't just abstract statistics on a spreadsheet. They represent totally preventable incidents. They really highlight this massive, dangerous gap between the machines we rely on to do our jobs every day and the respect we absolutely must maintain for the hazards they present. Let's look at how we can start bridging that gap. Here is how we're going to break it all down today. 1. Defining work equipment. 2. Management and maintenance duties. 3. Hand and power tools. 4. Machinery hazards. And finally, number 5, taking control with safety measures. Let's get right into it. All right, Section 1, Defining work equipment. Now, you'd probably think right off the bat that the term work equipment just means heavy industrial manufacturing gear. But actually, the legal definition covers literally any machinery, appliance, apparatus, tool, or installation used at work. And crucially, this includes any activity involving it, starting it, stopping it, programming, repairing, or even just cleaning it. Basically, if you're using it to execute a job, it's governed by this exact safety umbrella. Look at this list. It perfectly illustrates just how unexpectedly wide that scope is. We are talking about everything from a basic hammer or handsaw in your toolbox to the photocopier in your office, right up to a laboratory Bunsen burner or a massive lift truck. The whole shebang. This safety framework applies universally no matter what industry you're in. And because the definition is so vast, managing all this equipment safely requires a highly systematic approach. Which brings us nicely to Section 2, Management and Maintenance Duties. Okay, so before anyone even thinks about doing maintenance on a machine, we absolutely have to ensure secure isolation from energy sources. You can't just flip a wall switch and hope for the best. A physical lockout tagout, or LOTO system, is the gold standard here. You establish a physical padlocked break in the energy supply. This guarantees the machine cannot be accidentally reconnected while a worker literally has their hands inside it, because simply giving someone the right tool isn't enough. The machine has to be in a zero energy state. Now, during normal operation, the physical controls are just as vital. See this prominent red emergency stop button? These have to take total priority over any other operating controls. They need to be right where you can reach them easily, so you can bring equipment to a rapid but controlled halt without creating even more hazards. And here's a key concept. If a control system fails, it must fail safe. Meaning, if it breaks, it defaults to a safe, powered-down condition rather than a dangerous one. That kind of built-in safety is amazing for fixed machinery, but what happens when the equipment is entirely loose in your hands? Let's scale things down a bit for Section 3, Hand and Power Tools. We use portable power tools like this electric drill and belt sander so often, don't we? And honestly, because we use them constantly, it's super easy to forget that they bring a whole new level of risk right into the palms of our hands. Unlike a heavy, bolted-down machine, you're the one bearing the weight, managing the stability, and dealing with a trailing power cord, all while the working end of the tool is spinning at incredibly high speeds just inches from your body. It's a classic case where familiarity breeds a really dangerous level of complacency. If we break down the specific dangers of these tools, a really clear divide emerges between mechanical and non-mechanical hazards. Mechanically speaking, a drill presents obvious risks of entanglement around the spinning chuck or direct punctures. A sander? That threatens severe abrasion or drawing your loose clothing right into the belt. Non-mechanically, both expose you to noise, severe vibration, and electrical faults. But notice the sander. Actually, think about the dust for a second. It generates substantial dust, which isn't just a respiratory hazard. It's a massive, highly flammable explosion risk. So, to combat these super dynamic risks, strict general safety rules have to be our first line of defense. You've got to rigorously pre-inspect your tools for casing damage or frayed cords before you even think about plugging them in. And never carry a tool by its cord. Complete physical disconnection from the power is mandatory before changing a drill bit. Electrically, using an RCD, a residual current device, is absolutely crucial to instantly trip the circuit and stop a severe shock. Combine all that with solid footing and the right PPEs, and your risk profile drops dramatically. But if handheld tools are this hazardous, wait until you see what industrial machinery can do. Let's step it back up for Section 4, Machinery Hazards. When we deal with larger machine parts, the mechanical hazards escalate exponentially. We are talking about terrifying risks here. Shearing, where parts move past each other like giant metal scissors. Crushing traps, drawing in hazards where massive rollers can literally pull you inside. And it's not just the machine itself, it's what the machine can throw at you. Imagine the catastrophic impact of a high-speed abrasive wheel bursting apart and launching shrapnel across the room, or high-pressure fluid injecting straight through a heavy work glove. To neutralize risks of this magnitude, guesswork just won't cut it. Thankfully, we have a way to handle this. Let's look at Section 5, Taking Control with Safety Measures. To neutralize these risks, we rely on a strict, prioritized sequence. It's known as the hierarchy of control for machinery guarding. You don't just pick whatever option is cheapest or easiest. Step 1 is mandatory if it's practicable, enclosing the danger entirely with fixed guards. Only if that is structurally impossible do you step down to Step 2, protection devices, like invisible light curtains that instantly stop the machine if you cross the beam. And as a final, absolute last resort, Step 3 uses protection appliances, like using a wooden push stick on a table saw to physically distance your hands from the blade. Let's compare our primary guarding options, because it highlights exactly why good design matters so much. Fixed guards. They are fantastic because they are simple, low cost, and have no moving parts. But their fatal flaw is human behavior. If a worker has to unscrew a fixed guard constantly to oil a machine, they are highly likely to just leave it off. That's where interlocking guards come in brilliantly. Open the guard and the power shuts off automatically. They allow super safe access and are incredibly convenient, but they do rely on complex electronic switches that require strict testing to make sure they haven't failed. Wow, okay, we've covered a vast amount of ground in this explainer today, from the deceptively simple definition of a work tool right up to the heavy-duty safeguarding of industrial machines. So as you walk through your own workplace later today, I really want you to look around and ask yourself, are the everyday tools and machines you trust actually secured by these life-saving controls, or is simple complacency masking an unmanaged hazard right under your nose? Keep that in mind, stay safe out there, and thanks for joining me.